Física en 8 minutos resumido. The first stage starts with the introduction to physics. Physics studies matter, energy, space, time, and their interactions. There are two types of physics, classical and modern. Classical has a field of observation limited to sensory perceptions of a man, while modern physics is broader. It is beyond the sensory limit of the human being. Classical physics contains mechanic, acoustic, optics, thermodynamics, and electromagnetism, while modern physics study relativistic physics, quantum physics, atomic physics, nuclear physics, physics of particles, and plasma physics. Physics can also be called the science of measurements, but what is a measurement? A measurement is the comparison of a property or physical magnitude with another of the same class, which is taken as reference. It is assigned a numerical value, adding a unit of measurement. And physical magnitude is an abstract notion that deals with generalizing some property of matter, like length. A unit of measurement is necessary to define in advance the measurement pattern, that is, to establish the reference. Some physical quantities are length, mass, time, temperature, amount of substance, luminous intensity, current intensity, and derived physical quantities are area, volume, velocity, acceleration, force, work, and power. The physical quantity is the physical magnitude that is measured in units or measurement patterns. The SI units are international systems that were established in France to standardize measurement patterns. The CGS system, or System Sigesimal, was founded by the German mathematician in 1832, Karl Gauss. It is the centimeter, the gram, and the second. It is widely used today, but it's almost been entirely replaced by the international system. Finally, we have the English system, which is the weird one that United Kingdom and United States still use. It is the foot, pound, and second. You need to know how to convert the English system to the SI units, so that is something you have to learn on your own. Kinematics. It is the study of types of movements that our body has, and it can have a mathematical description. Movement is the change of position of a body, distance is the space traveled, displacement is the distance traveled in a straight line, velocity is displacement over time, speed is distance over time, acceleration is velocity over time, mass is the measure of the inertia of the bodies, force is the agent capable of producing a change in the movement of bodies, weight is the force in which the earth attracts a body due to the attraction of gravity. In stage 2, we see the basic concept of kinematics. Mechanical movement studies mechanics. It is the simplest among all the forms of physical movement. Mechanics studies the movement of bodies in general. It can be divided into parts, kinematics and dynamics. Kinematics studies the movement of a specific object in space, while dynamics studies what causes an object to move. So first we have the differences of distance and displacement. Distance is how much you traveled, and displacement is how much you traveled in a straight line. So we also have a difference between speed and velocity. Speed is the distance traveled by a specific time, while velocity is the displacement traveled in a specific time. We can also find acceleration thanks to velocity. Acceleration happens when there is a change in velocity. The formula is final velocity minus initial velocity over final time minus initial time. The units of this is meters over seconds squared. Force is the mass times acceleration. Weight is very similar to force since weight equals mass times gravity. Gravity is the type of acceleration. 9.8 is the acceleration of the Earth. Speaking of gravity, there are two types of forces in nature: the gravitational or gravity forces, and the electromagnetic forces and nuclear forces. The first law of motion is that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. The second law of motion states that if a body is under the action of a net force other than zero, then the acceleration produced is directly proportional to the force and inversely proportional to the body's mass. The third law of motion is to every force of action there corresponds another equal force in the opposite direction called reaction. So in the early times, it was thought that the Earth was the center of the universe. This was the geocentric theory of the universe. It stated that the planets moved around the Earth until Nicholas Copernicus appeared and said, no, the sun is the center of the universe, which stated the heliocentric theory. Later on, the German Johannes Kepler stated his 3 laws of the movement of planets. The first law is that planets move in orbits of an elliptic form around the sun. The second law is that the imaginary straight line that unites the planets with the sun covers equal areas as intervals of equal times. The third law is that the squares of the orbital periods of the planets are proportional to the cubes of their average distance from the sun. Then Isaac Newton came, and he united all the theories of Copernicus, Galileo, and Kepler and stated a new law, the law of universal gravitation, which states that all bodies in the universe move under the same laws, no matter if it's here on Earth or in any other planet of the universe. Newton also discovered the formulas of force of attraction, the gravitational force, and the acceleration due to gravity. The force of attraction is when 2 objects are attracted to each other. This is the formula. The gravitational force is the gravity of a planet. On Earth, the gravity of this planet is 9.8. This is the formula. And in acceleration due to gravity, it is used to find the acceleration of a falling object in a certain planet. This is the formula. Work and power. Work. What is work? It is the activity that represents a physical or mental effort. The formula is work equals the force times displacement times the cosine. The cosine is the angle on which the work is performed. We also have power. Power is the work done in a certain time. Energy. Energy is defined as the capacity to perform work. There are different kinds of energy: thermal energy, electric energy, chemical energy, radiant energy, nuclear energy, and mechanical energy. Mechanical energy is the energy of a moving object. This is the formula. We also have potential energy. This is the energy of when an object is still. This is the formula. And finally, we have the mechanical energy. This is the general energy of an object. This is the formula. And finally, we have simple machines. To be honest, I don't understand any of this, but I do know the formula. This is the formula. If you only have the mass of an object, remember to convert it to weight. Remember that force is mass times acceleration, and weight is mass times gravity, and gravity is a form of acceleration. So you need the weight to have the right force. So basically you need to multiply the mass times 9.8, which is the gravity of the Earth, and then, well, times the distance of the fulcrum. And that is it. Thank you for watching. I hope you don't fail, and good luck.